This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. So welcome to the Math Map Book Club, where Kirsty Gilpen and I each week discuss the curriculum used in the Classical Conversations communities. We're so grateful for the other parents who join us and for those of you that send in your questions. Today is my birthday, April 1st, and this is 2026. So you can all guess how old I am if you want. But anyway, the team was just sharing with me about how our days are appointed in the scriptures, and our birthdays are an important day where we've been appointed to serve God here on this earth. So thank you, team, for being so encouraging, and I look forward to more of seeing the unseen and the good ideas that you guys have as we talk today.
Well, thanks, Lee. As always, we appreciate you, and we're glad we celebrate your birthday because we appreciate that God brought you here and gave you this work. So, and that you've been faithful in it. So thank you for that. So today we are looking at, as I find my screen here, we are looking at lesson 30, reflection. So this is the concluding episode for our 25-26, the Math Map at Home edition of our book club. And so we have made it through all 30 weeks, and we're going to talk today about what that reflection might look like, but we're also going to talk about how you can continue that conversation into the summer. So as we have every week, we're going to talk about our flashcards, and I'm not going to highlight necessarily any one of those ideas that are there on the screen because we've talked about them so many times. But what I want you to remember is that the flashcards are such an easy way to either become familiar or maintain that familiarity with those calculation facts or those notations or those equivalencies, or with our two new decks that are going to be released, I think today. So, or this week, they'll be for sale. So we have the two new decks, which are algebra and trigonometry. And I want to encourage everybody that although those sound like they are designed for our challenge or upper challenge students, that's a thinking that's a holdover from our traditional linear curricula that say, no, we're going to hold off on those ideas until our students are older. Instead, as classicalists, we know that even our youngest learners can start loading the grammar, not necessarily understanding it, but they can certainly memorize. And so there's a lot that they can memorize in those algebra and trigonometry flashcards that will set them up to be successful when they are in challenge or wherever their math studies take them. So if you haven't already been looking at the bookstore website, looking for those flashcards, I would encourage you to do so. I'm excited about those, and I think that they're going to be helpful to our families who are looking to take their knowledge and continue working through flashcards.
Percy, we had a question. Do you know if there are more flashcards after these two?
Yes. So the next two sets, and I think that they will be the final sets, unless we come up with something where we go, oh, that would be another great set. Next year, there will be a set called Geometry that will focus on shapes and geometric relationships. And there will be a set called Relations that will look at all of those different relations and functions, the graphs with their names, understanding the general form. Each of those sets is actually going to look at transformations, but in a little bit of a different way. So we'll look at transforming relations in the relations deck, transforming points and figures in the geometry deck. We'll also in that relations deck will include derivatives and integrals and inverses. So yes, those will those will round out what we're expecting will be all of our math flashcards next year. Of course, it's really hard to limit, right? These are the 140 things we should know. So I always have ideas. If Lee said, yes, create another deck, I'm sure we could come up with things, but we don't want to overload because there's a lot of grammar, and I think that that's probably hits all the highlights in those sets.
You mean like how we're trying to limit what's in the glossary?
Oh, hey, there's a digital resource. I don't think I have to have any limits there.
Percy loves adding things to the glossary. So if you find a word that's not there, she gets very excited when she can add a new word to the glossary.
I do. Although the new words are coming slower and slower. All right. So our lesson 30 book does have a cover that's not a lot more than the cover. And so we do encourage you to continue to have that conversation using the cover as a stepping off point. So this week we're going to look again at our canons of rhetoric as we look at our cover. And a Memoria question is just, how does this cover help you to remember? We've talked in the past about maybe what it helps you to remember, but we can also engage our students in how does it help you to remember. Asking our students to identify the things that help them and how they help them can then actually help them to figure out, well, what could I create for myself? If having a picture helps me to remember things, then maybe illustrations would be good for me to include in my notes that I make that I want to remember. Instead of your students inventing, a good invention question would be to ask, how do you think the artist came up for the idea of this art? We know that a lot of you really enjoy researching the art and the artists, and so you may find out what the actual invention genesis was, but it's also good to say to your students, why do you think they came up with this? That may be an easier way to help them think through how to come up with ideas for themselves by thinking about it through another person. We've talked about the arrangement of the page and all the different pieces on the page, but we can also talk about the arrangement of the art in terms of why did the artist arrange the art this way? And what were they trying to tell us in arranging it this way? Why do you think that Rodin would have wanted the thinker to be sitting down instead of standing up? Right? That's an arrangement question. And so asking your students, what does that convey to you about the message of the art or from the artist? Rewriting our quotation and reflection using our elements of style. We talked about that last week, and I think that's still a great way to approach that this week. As we talk about how we can take those things and still practice with them without changing the meaning. And then our delivery, right? Considering the size of the art is always helpful to us to think about how it was delivered. You won't have a math map this week. Lesson, and I just realized I didn't fix that. It doesn't, lesson 30 is a blank booklet. It is a little bit different to lesson 29 because lesson 29 is entirely blank pages. Lesson 30 has blank pages, it has lined pages, and it has gridded pages for your students to use as their blue book. And for our challenge students, that is intended to be a blue book for all of the strands so that tutors or parents no longer need to actually buy a blue book, but instead they can use this book for their blue book for all of the strands. Now, if you don't have a student who's in challenge, we're going to talk about some things that maybe you could put in there to act as an assessment for your student. But again, I would pull that map from another booklet and just help your students to see we've made it, right? We've made it till the end of this year and to look ahead, right? Where are we going next year? We're going to do the same column, but right, or the same rows, but in a different column next year. And so that's a way to celebrate the conclusion of this year while also looking ahead to next year. When we think about reflection, I was thinking about the fact that there's really two different ways that we assess. And our informal assessment is an ongoing process. It's usually task specific. So I may be asking my student questions or looking at how well my child sits at the table and noticing that this week they did better than last week, right? I'm constantly assessing, or perhaps I've noticed that they can't add, once I ask them to do 3-digit numbers, they don't have the attention span, or there's something that's not clicking for them, right? And I notice that right away and I address that. And so that informal assessment can be their physical skills, their academic skills. It can be our character, right? I know that as a mom, a lot of the times I would say our issues aren't necessarily academic. It's a lot of it's character. It's not that they can't do the work. It's maybe that they don't want to do the work. And that's sometimes a little bit harder because I could explain the math, but I couldn't always mold that character as quickly as I would like to. When we think about reflection, though, we're really thinking more about a formal assessment. That something typically is scheduled and it's a look back, right? We're reflecting back. I think that when we're talking about an assessment that has a reflective quality, we want to be looking at our goals. So instead of looking at individual tasks, are we able to do individual tasks? I want to assess compared to the goals that I have set at the beginning of the year, or if I had an adaptation in the middle of the year, I want to be able to look at those goals and say, how are we progressing towards those goals? Right? How are we making progress on those goals? And those can be progress on our big goals, right? So I always used to laugh and say my primary job as a parent was to take this precious little baby and get them to adulthood safely, and so that they're prepared to go and be contributing members of society who walk closely with the Lord, right? That was my goal. And so each year I wanted to see progress towards that goal. I could also have specific goals for that year. And again, they could be physical goals or academic goals or character goals. But a lot of the times when we're thinking about our reflection and our formal assessment, we may have some academic goals that we're trying to assess to see how well are we moving. The math map is a great way to look at that and say, okay, well, what are the big ideas of the math map and how are we progressing in becoming familiar with those or understanding those? So there's a lot in lessons 15 and 30 that address assessment. And we've talked about those quite a bit in other book club episodes. So I was sort of going to not talk too much more about that other than talking about if you don't have a challenge student, what do you use that blank book for? And there are ideas, again, in charts 15 and 30, there's a lot of ideas there. But I wanted to encourage you that you can still be putting things in that booklet for your student for all of the things that you do. So you may choose some work that you feel is reflective of the growth that they saw. If you used a math map in order to keep track of what you did or things that you missed, you could maybe include that. You could ask your students to draw pictures. You could ask your students to write short paragraphs. There's a lot of different things that you can do that can form that same sense of assessment, whether it's you filling that booklet for or inviting them to fill it with you in order to reflect back on your learning for that year. So it still becomes a record for you, even if it's not the same formal Blue Book experience that our challenge students have. Does anybody have any questions about reflection and what that may look like at home?
I had a question, Kirsty. And I'm thinking back on my educational experience with my kids. We did Blue Books in CC, but did you do them at home too? Did you do some kind of Blue Book type assessment at home, or or some kind of goal? Like, how did we do on our goals? Anything formal?
I did not. I wish I had. I will be very honest. I am not your model homeschool parent. Um, I wasn't your model homeschool parent. And there's a lot of things that I wish I could go back and do differently. And a lot of the times by the end of the year, I was just really glad that we made it to the end. And I was as ready for summer break as my students were. So I wasn't very good about doing this, but I wish that I had been. And I think that providing all of our families with these two blank books at lessons 15 and 30 are an opportunity to for a gentle invitation into that more formal process, because we're not trying to make it, if you think about those baby books, your first one, you have the baby book where you've got everything written down and it's got all the prompts and you're like, you keep track of everything and there's pictures, and then your second one comes along and there's a calendar, right? And so you maybe have a few notes on like the first 8 months, and then all of a sudden nothing happened those last 4 months of that first year. Um, so I think what we want to do is provide a very easy way to make some notes, right? What did you feel like went well? What would you change? What do you want to make sure you hit the next year? I think it becomes, for a parent like me, I think I would have used these booklets as just a way to capture my thoughts. Wow, this went really well this year. Or we skipped lessons 15, 16, 17, and 18 because things were crazy. And I want to make sure I hit those next year. Um, and again, we can use it holistically. So I might say we really enjoyed reading The Hobbit. We're going to read The Fellowship of the Ring next year, right? Or or maybe a note that The Hobbit was rough. My kids aren't ready for The Fellowship of the Ring, right? So those kinds of notes are a thing that you could put in there as a parent, so that if, like me, you go, it's summer and we're just going to play and have fun. When you come back around to July and you start looking ahead at the next year, you've got some notes that you can sort of start from to remember how you ended the last year. So,
I think we did certain things. Like I always felt like my boys were better at Latin. They had surpassed my knowledge. And so I always gave them some little assessments at the end of the year from, it was another Latin book that I was using as an answer key to go along with Henley. And I would use a couple of pages out of that and give it to them. So I think it was like certain things that I wasn't really sure exactly where they were. I would give them something a little extra than what they did in community. But I loved reading, like the tutor would, give back their blue books, and I enjoyed reading feedback from the tutors. So, I mean, even though they took a blue book, um, in challenge, we did a couple of things extra, but for the most part, we just chose whatever, they did in community. And then I just enjoyed reading the feedback, reading what they submitted and then reading their feedback afterward.
Yeah, and to tag on to that, I didn't do anything else at home myself either, but I always try to put an appointment on the calendar with my kids, like an individual, we're going out for lunch, or even if we stay home, maybe I make tea and cookies or whatever. And I have a time that my student and I look at their blue book together. And I do try to look at it. I try to read through it first and have a few extra things to say. But that's been kind of a special time. I haven't always done that well, but when I have done it, it's been so rewarding. And that's something I've encouraged as a challenge director. I've encouraged my parents to do that too, because it's the end of the year. Yeah, you slip that blue book in somewhere, it gets lost, nobody ever looks at it, and it's like, well, that's not very rewarding. Like, why did I put all that effort into that if you just glanced at it and filed it away or whatever? So anyway, that's not really what your question was, Kristen, but I just thought about that. I'd like to encourage other people, just make the blue book. You could spin off of that too. Like okay, I love what you did here. Now, could you write me a paragraph on this or flesh this out more or like do an addendum instead of a completely different thing?
We call it bubble tea and blue book or B&B meeting. So kids love bubble tea, by the way. So.
I love that. Although I want to go visit Jana and have tea and cookies. So
Well, I want you to come visit me and have tea and cookies. Come, everybody.
party at Jana's house.
Yep, let's set a time. I'm ready.
We can have boba tea too, Yating, right? We can have. So
yeah, I've got boba.
It's like chewing your tea. Some people don't like to chew their tea. So.
Yeah, I'm not sure. I've never had it, and I'm not sure. I'm very on the fence because I like my regular, like in England they call it like builder's tea, right? Just black tea. And yeah, I'm not sure about something in it. So one of these days maybe I'll be brave.
You have to think of it as something different. Don't think of it as tea. Like
Tea.
I'm going to have a boba. It's something different. Yeah. I also want to say, I don't know if you're finished, but you keep calling this a blank booklet, and it is not blank. It has an amazing chart in it. I love this chart. And I think it's a good assessment tool for me as a parent. I love looking at it each year and be like, oh, no, this is so familiar to me. This one page is really familiar. That's so exciting. Not that I understand it, but I'm building some grammar. And I love the questions on that back page. And I know this book club's focused on what we do at home with our kids, but I just want to say that we looked at this in Community and Challenge 3 last year on our Blue Book Day. And I had everybody I just set a timer for 2 minutes. Nobody's allowed to talk, and they just read over it. And then I had them tell me what their plans for the summer were and how they see math in what they were going to be doing that summer. And that was a really fun conversation.
Well, that's great. And I appreciate that. Yeah, those the charts have some extra questions there. So if you're looking for more questions to ask your students, they're less math sort of content specific and more sort of how do we see the unseen type of questions. And they're also in the companion. They're related to, if you click on the more questions, you can actually see a compass that's got 9 questions every week. And those are a subset of the ones that are on there. So if you're looking for how to sort of scale those, that's in the companion. And then, Lee pushed us to do well on chart 33, where we see that list of the functions and their graphs and their inverse and their derivative and their integral, right? And so we worked to try and get that right as a visual summary of what we had done through the math map, especially as it relates to the functions and the relations. So that said, let's go ahead and now turn the page to talk about that last page, chart 34, and those activities, because we keep emphasizing that our goal is to help families see the unseen through math. And that's probably the easiest way to continue the conversation into the summer, is to keep encouraging your students to see the unseen. That means finding math in everyday activities, or practicing the skills of learning in new ways, or picking a question. And so I've got 2 suggestions here that you could pick a question that you can just keep asking your students all summer, the same question, right? So for example, you could say, how does this remind you of something you learned this year? So different activities, say, how does this remind you, right? What does this remind you of? Or more specifically, which booklet is most closely related to this activity, right? So if you wanted to know more about the math that you're seeing here, what booklet would we go and look that up in, right? Because we don't expect, here's a great reminder, that the charts are not there to be memory work. We do not expect, unlike in Essentials where we ask kids to recreate charts, we are not asking anybody to recreate the math map charts. But isn't it a great goal to be familiar with where the big ideas are in the charts? So I know, right? I have it's a small size, but I have a book of charts. And so when I'm doing things and I want to make sure that I have it correct and I'm not always trusting my brain, right? I know, oh, I know that's the chart. And I go to the chart and I find it. So I don't necessarily remember every detail, but I remember where it is. Right? So if I, for example, I don't know why, but when I was visiting Kate, we went out for frozen yogurt with all of the other dancers. And there was something, this is really weird that I'm remembering this, but there was something there where I was like, oh, that's like a difference of 2 cubes. I have no idea why that happened. But now I am not good at remembering the formula for the difference of 2 cubes. And so that's where I would go, oh, well, that's on chart 6-4. I know where it is on the page, right? I maybe don't remember exactly where my pluses and minuses go, but I know where to go and look it up. And so when I talk about the booklets or what remembering things is that over the course of time, not in 1 year. Remember, I've been working on this for 9 years. I am somewhat intimately familiar with the charts. I should know where things are. But over the course of 13 years in the math map, right, or 12 years in the math map, hopefully students go, oh, wait, that's on this chart. Or I know that that's back in 1D. And so by asking our students to think through what booklet is closely related to this, we're helping to build that familiarity of where to go and look in their resources, right? So that whole idea of knowing your resources. So those are the things that we can do. And then here are some of the places. And so here's the list. This is not the detailed list, but the main list that's on the back of chart 30, so chart 34. And so I thought I would just pause here for a minute and see if anybody has any plans for their summer or ideas for their summer that are generated from this. So are there any, like for example, I just got new windows put in where my office is. I'm very excited. So now I have to put the trim around the windows, which is very mathematical because I need to make sure that I miter the corners of the trim correctly, that I have the correct PSI on my nail gun, that, right, my measurements, I want to be as accurate as I can be with my measurements. I had to measure and then plan my materials. So I had to order the right number of materials. I had to know how much caulking I would need. So I bought enough caulk, right? So you can see there's an awful lot of calculation that goes into this project that I have that seems so straightforward that I'm just going to buy some wood and stick it around my windows, right? But to do it well, I'm going to use a lot of mathematical ideas. So there's an example. So I just thought we'd pause here for a minute, and I would love to hear your ideas or your plans for how maybe through some of these activities, you and your family might practice math this summer.
Well, following right along on that construction theme, my husband and I are remodeling that's not even the right verb. Oh my goodness, it's a 125-year-old farmhouse that we're completely gutting, and like it's intriguing to me. I'm not doing the math that the structural engineer is doing, but just trying to follow along with their ideas as they're giving us like what kind of beams we need and how we're going to support this structure. And yeah, I'm listening to my husband talking to the structural engineer, and he is a construction guy, and it's like, oh my goodness, there's another language that I don't know. Like all this grammar that we talk about all the time, it's so true. Like that's a subset, math, construction, whatever. They're using abbreviations and terms and like I really feel like I'm listening to a foreign language. So that's one place we're doing a lot of math in our lives.
I
Jana's going to be
remember
making a whole new set of flashcards for herself.
I
Great idea.
remember one video that you did talking about like taking a string and putting it in the middle of a garden and then making a circular, you know, I guess map of things. Tomorrow we're getting a refresh on our pine straw and mulch and stuff, and I want to put some mulch around a circular part of plants. And I picture you saying how you go in the middle and then you make the circle and stuff. So as soon as we're done with the book club, I'm going to go out and make my circle so that they know where to put the mulch. So
Oh,
it's
yay.
fun.
There were a couple in the chat getting a new pop-up trailer, calculating the tow weights, using art, finding art around all summer, painting, inspired by the math art relationship that we enjoy in TMM, and traveling internationally, so calculating time zones and the hormone level. That makes me laugh. The time zone thing, I don't know why, but that is really hard for me. And I don't go internationally, but we serve a lot of different time zones. And so when we are planning calls, I have a cheat sheet now that I'm like, somebody will say, well, what time is it my time? And I'm like, I don't know. So I have to go look at my cheat sheet and count backwards or count forwards based on my little map of where they are located.
Yeah. Well, I'm gonna have to fly back to Taiwan, and then my husband and the kids are gonna fly to Switzerland, and I'm gonna escort my mother. Hopefully, this is her last trip, and we're gonna go to Switzerland and meet them. And I'm gonna fly back to Taiwan, and then fly back to the U.S. So this summer.
Oh, I'm tired just thinking about that, but also a little jealous. Switzerland will be so pretty.
Yeah, it's on her bucket list to see the Matterhorn and cycle to, just one of those things that we want to make it happen. But my mother, if you can think about praying, it's she's pretty much on her last leg.
Well, I'm glad you're going to have the opportunity to do that with her. I know that'll be special, and we'll certainly be praying.
Yeah, I hope so too. Thank you.
It just made me think, just in trying to think how I can say this, right, that math also, and our conversation about dimensions gives us another way of thinking about those transitions, right? That if we're believers, we're already living an eternal life. And if we think about, right, we can picture, if there's two dimensions, right, we can picture, um right, I have these two dimensions, and they're separate, right? They don't intersect, right? And but yet, if something inhabits them, they're still there. And so if we think about, our third dimension that we inhabit, and somehow, right, in four dimensions, there can be a whole other three-dimensional space that we don't see, but is fully alive, right? It gives us a way of not just picturing like people floating in space, waiting, right? Whatever heaven is, but it gives us a language of what does that look like. And so I think that even there we can use our mathematical understanding that we're starting to approach, right? The ideas of the eternal and the infinite, and what does that mean? And use math to help us maybe find comfort even in those hard transitions. I hope. Jana, you were going to share something.
Sorry, I have no idea. I'm sure I was. But I love what you shared. So good.
Percy, there was a question in the chat, and I think she was talking about um, how the booklets are. She's like, is there a list somewhere that says what books are related?
We feel like we have been working on that, but it is so if you are in the companion, this has not been like finished or pretty. It is still rough. But if you're in the companion and you go to any particular booklet and you click on the math map down at the bottom, I think there's a button that sort of says like the math map connections, something like that. And if you click on that, it'll actually change it from the regular math map to a math map that sort of shows like the lessons that build up and then the lessons that follow on. So for example, if you're in lesson 25, you might see lesson 11 highlighted and lesson 18 highlighted, lesson 16 highlighted, pointing out that there's where some ideas started. And then you might see the lesson 26 highlighted because 26 is going to build on 25. As you can imagine, there's so much content that we're creating that has been a portion of the companion that I think will be really great. But right now, I think the information is there, but just know that it's not going to look perfectly finished. So hopefully that'll give you the information you're looking for. It won't be polished yet.
Is it on the map itself at the very bottom? If you open up the companion, you find. Oh, okay.
Yeah, if you open up the companion and let's say you open up booklet 25 and you flip to the page, the math map page, there's a button down at the bottom of that page.
And is there like if 25 is connected to the 18, then if you go to the map on the 18, then it will connect to 25. Ooh,
Yeah.
how fun. Yay, that's great.
Yeah. So and that's kind of like the, if somebody's like, "Ooh, I would really like to work on like making this better." Feel free to like send us suggestions because like I said, it's not polished yet. And we're certainly open to suggestions if you think that there's a really good tie-in that we've missed. So,
Are there other hidden gems in there like that? Because I didn't know about that little button. It's fun.
I don't know.
Unsearchable riches.
That would be our summer project. What do we do in the summer? We really dig into the companion. Because to be honest, when every day our kids are doing the lesson pages, we don't really look at the companion. In fact, some families has talked about like they hate to go and open up a laptop and that can be disruptive to their homeschool day. But summer will be a great time to do it. I plan to just open it on the iPad and have my kids just browse and explore and then look at videos and see what's there.
That'd be great. How about is anybody a sports fan? What big sporting event is coming to the United States this year?
Oh, I don't know. I was just thinking Final Four is coming up.
Well, yes, there is the Final Four, but it's the World Cup. And one of the reasons why I think the World Cup is so neat is because where so many of our sports activities are US centered, right? We have the World Series, which is all American teams, right? You have the championships, the world champions. Well, yeah, but they're all American teams. And so we're very US centric in our sports here. Whereas the World Cup, I mean, it matters in the rest of the world in a way that it doesn't matter here, right? I mean, it is this huge sporting event and it's happening here and it's an opportunity. I just think this is a great opportunity for families to, I mean, there's stats you can talk about. You can look at travel and maps, right? How far did teams have to travel to come, right? If you have older students, you could look at some of the questions like, does playing in a particular city, because it's spread out, right? It's all over the United States, and there's a location in Mexico. I mean, it's a really spread out World Cup, and so talking about that, does that favor a team? Are there any teams that are going to, be hindered by that? There's a lot around that. So if you have a sports-minded family, that would be a great event to use as a jumping off point for some math conversations. Right? I mean, there's geometry on the field. I just remember, well, from a little bit of soccer and a little bit of field hockey, right? the triangles that, you're always trying to maintain on the fields because certain passes are better than others. And so you're trying to pass this way or this way and not diagonally, I think. Right. So all that language is geometric language. And so engaging our students in those conversations. But it's also that opportunity to talk about things that matter to a world that sometimes we don't always get to think about. We've talked about construction. There's books, right? We can certainly talk about our books as any of the books that we have, but there's a lot of math sort of centric books out there that you could engage with if you were looking for some ways to have some math conversations, right? Just cooking, cleaning, taking care of a house. Right? There's a way to invite your students in to some of those activities and talk about math. At this time of the year, right? You can talk about taxes. Right? There's a great opportunity to practice percentages and talking about where integrating that idea of mathematics of taxes with, right, what do our taxes pay for? What do they fund? Who do we pay taxes to? What do the different taxes, right, pay for or do? And so engaging our students in those activities are going to help us to have that conversation that's both mathematical, but again, it's seeing the unseen, right? Because we're helping them to put that math into context of some life skills or things that maybe they don't normally get to see in their typical academic work. All right. So that's right. So that's one way we can continue that conversation, right? Just continuing to push to see the unseen, using our activities, right? All of those things that we are going to be doing this summer, but making an effort to engage and say, well, what are you seeing here, right? How are you seeing math here in order to continue that conversation? We can continue that conversation to practice specific skills, right? So we can think about calculating, right? If our students have perhaps need some extra practice with calculating with fractions or 3-digit numbers, or perhaps their multiplication isn't the strongest, or division, right? We skipped over division because it just seemed like a bridge too far. This is an opportunity to come back and to spend some time practicing calculating where that's all we're doing. Right? Flashcards, again, are a great way to do this. Quick flip arithmetic, using cards to generate lots of practice problems, playing the games that are in the math map or through quick flip arithmetic, right? That's a great way to practice calculating over the summer. So it can be drill sheets, right? We can create drill sheets where we have our students do that, but we can also make it fun by doing it through games. And then we can also continue to practice our vocabulary and our grammar. So again, flashcards. Notice I'm weaving in the flashcards that we can continue to use those flashcards, whether that's a review, looking at the flashcards we've already done, or whether that's a preview, right? Maybe we buy those new flashcards decks and we start previewing those, reading through those a few at a time together. You could pull the charts out and ask them just to go through on a lot of the charts. There's a section that might say like terms. And now that I've looked at, I'm trying to find one that has that very clearly, right? So like on chart 10, down at the bottom, there's terms and notes. And so I could just if I'm looking for some more words that maybe aren't in the flashcards, I could go, okay, collinear. And here's the word. So we could just look at a chart and go, well, what are some of the words in the charts that we might want to practice this summer? Or you can use the glossary. We've talked about that. There's more words in there than you're going to get through in the summer. But even just encouraging your students to look at the glossary with you and pick out. Right? Maybe you say, okay, we're going to go pick 3 words out of the glossary. You can pick any 3 words to practice this week. So now they're looking through the glossary and they're becoming familiar, less so about practicing the grammar and the vocabulary that's in the glossary, and more as a way to engage them with that resource. If I want to know what a word is, instead of just guessing, I can go look that up and actually find a definition and an example. So
I think
that
we can practice the skill, like we can think in terms of skill sets too. I felt like this whole year my kids are just naming. They're just naming, they're memorizing using the flashcard. But in the summertime, I can have them attend more and even give testimony. And so I'm excited about the highlighter set that's coming out in bookstore. It's meant for the expositions strand, but I thought this color highlight, I can have them say, hey, this is mom's gift to you for highlighting set for your next year, but use this highlight and just highlight and attend your charts. I thought that might be fun for them to just color code however they want. Do you have any suggestion for how to color code math map charts?
Well, I make the master students, so there's a course where the master students go through the math map sort of almost 3 times in the course of the semester in different ways. And one of the things that I encourage them to do is to use 3 different colors, and they have to highlight the things that are familiar, the things that are unfamiliar, and then highlight where they can make connections between different ideas. Or they might say, this is something I have never seen, I don't remember at all. This is something I've seen but don't know anything about, and this is something that I'm more familiar with and more comfortable with. So those are a couple of different ways that I've given my students to highlight. But you could come up with your own things, because you could say, okay, I want you to go through and find everything that feels like it's related, depending on your student and what you're trying to do, right? Everything that feels like it's related more to arithmetic. Find the things that feel like they're more related to geometry, right? Go and find, right? Maybe you say, okay, what's a one-dimensional idea? Well, anything that's about a line, anything that's about a linear measure, right? So go through and look for all the 1D things. Now go through and look for all the 2D things. So I think you could do this over the multiple summers and pick different ways of highlighting your charts. I think that's a great idea. I love that. And I love the fact that you're saying, let's practice our skills, because that's what we keep coming back to, is that it's about the skills and not the content. The content is good, but the skills are the lifelong learning that we're going to be giving to our students. And so saying that this is an opportunity to branch out and use a different skill is a really great way to use your summertime.
That's one thing I've really enjoyed about this particular book club is that just honing in on the skills, like looking at the artwork, what skills are we using when we ask certain questions? Because I think I mean, a lot of parents don't know how to do that yet. And so I love those suggestions. And I think some of our tutors and directors are some of them are still learning as well. I mean, I remember probably only about 5 years ago is when I really probably understood how to start teaching classically. And we've been doing this since my kids were 4 and 5. So it takes a while to get out of the mindset of traditional schooling. And so that's what I've really enjoyed about this book club is really giving specific examples of questions that you can ask your student when they're looking at the cover, when they're looking at the eye pages, when they're looking at the lesson pages. So I think this set will be a really good set to share with people, especially those who are brand new to classical education or, just learning how to dive in.
All right, one last way to continue the conversation, and that's actually using the math map. So notice that so far we've talked about just whatever you're doing, right? Ask a math question. What do you see here? And continue the conversation that way. We talked about using some other resources to practice specific skills, whether that's skills of learning or whether that's math skills. But now, if you have your math map and you're like, okay, we got to the end of the year, but I want to keep my students still engaging with these booklets over the summer, what can you do, right? Well, there's a lot of things you can do. Here are some ideas. One, go back and look at all of those incomplete lessons. Did you only do 4 pages or 8 pages or 12 pages this year? That's fine. But guess what? You've got a whole bunch of pages that you could go back and revisit. So even encouraging your students to just go back and do 4 more pages of each of the lessons, right? Or pick out the lessons from that and say, okay, we're going to go back and we're going to do some of these pages that we didn't get to before. Let's go back and review. Missed lessons. As mentioned, I may have been not your poster homeschool mom, and there may have been times where life got in the way, or we traveled, or we did something, and maybe we missed a lesson. And this is a great opportunity to pull out those booklets that maybe it was a step too far, right? Things were going on, and so we didn't get to that lesson. We're going to pull it out now, and we're going to work on that lesson over the summer. This is where, if you've kept track in over the course of the year, was there an interesting lesson? Was there a fun lesson? Was there a lesson where your child had more questions and they wanted to explore and they wanted to know more, right? That's a great opportunity, again, over the summer to pull those lesson booklets out and say, okay, well, let's go see what we can learn. Right? Let's go find some great YouTube videos, or let's go and dive deeper. Let's see if we can make a model. Let's see what we can do, right? Maybe your child really loved constructions. Well, so now let's take those skills of construction, and like Kristen said, right, she's going to go and construct a circle for her mulch, right? So maybe if you have a student that says, oh, I really loved this, right? Take that opportunity to let them explore their interests that maybe you were like, okay, well, we've got to move on during the year. Now this is an opportunity to go back and say, okay, you can spend as much time as you want to here, go dig deep. I still remember how impactful it was, that in 9th grade biology, I was just fascinated with bacteria and petri dishes, and my teacher let me explore that for many weeks. I would sit in the back of our biology lab, and the whole class had moved on and was doing other things, and I was still back there playing with petri dishes. And she allowed me that opportunity to explore and experiment and do things, which I don't think is super common for teachers to allow students to do that. But that's what we can do with our summertime for our students, is give them that time to explore an idea that maybe got truncated a little bit during the academic year. And the other thing that might be a good way of using your booklets in the summer is, what were the lessons that were hard? Was there a lesson that was just really challenging? Well, let's go back and revisit that. Maybe it felt like too much because it was cold, or it was dark, or it was unfamiliar. But now that we've got a little bit more of the math map under our belts, or the weather's nicer, or whatever it is that may have made it hard, the situation has changed. And so let's go take a look at that lesson again. And this time we'll take a little bit more time, and we'll look at the grammar first. And then we can unpack those hard lessons, those more difficult lessons, and take the time that we need to on them. So that's a way that we can take those booklets that we've been working on all semester, and none of that needs to feel like it was wasted, right? Because I can bring all of that back and look at it again over the summer. So if we have 52 weeks in a year, and again, we have 52 weeks in a year, we have 30 lessons of the math map. That leaves us with 22 more weeks that we can go back and revisit topics from the math map. Right? So not all of them are in the summer, but I just want to encourage us that if we wanted to spend 2 weeks on a lot of the lessons, there's enough weeks in a year to do that. So that brings us to our reminder of how we're here to help you. It doesn't end in the summer. We continue to be here to answer your emails, to provide the forums and help for tutors. Your community might end, but your family does not. And so you continue to have one another that you can work with collaboratively. And our book club does continue. So next week, on April the 8th, we are going to start our summer series by beginning, and we're going to try and go slow. I was working on the slides, and I started to get a little bit ahead of myself, and I backed off that we're going to not overload everybody. But next week, we're going to talk about what is a unit. It's something that I think it's a word we use a lot in the math map, but in math in general, we talk about units a lot. And so next week, we're going to talk about what is a unit and how can we practice knowing what our units are. So I hope that you will come and participate in our summer book club as we take a look at units, and then how do we combine them, right? How do we add them, subtract them, multiply them, divide them? How do we do that? How do we count them? How do we place value? So I'm excited. I think that this is going to be a great series this summer. So I hope that you will participate.
Should we call it like a arithmetic boot camp or something so that people, everybody wants to jump on the boot camp bandwagon. So we have one too. Just come do our summer arithmetic boot camp.
I like that.
The initials are ABC. How about that?
Ooh, I like that. Although now I've got the Jackson 5 in my head singing the ABC, 1, 2,
That
3,
could be your
ABC,
theme
right?
song. Start it.
So, as always, we like to give you the opportunity to ask questions or share testimonies. So, if you have any questions or anything you'd like to share, I know that we are starting to get some new people joining us on our live calls, and that is super exciting. We're glad to have you here. And I just want to point out that Kristen and Yating and Jana are beautiful women, but they are not special in the fact that they weren't invited here or have a special some kind of special standing. They've just been part of our book club because they show up every week. And so whether it's your first time or gosh, we've probably got hundreds of episodes now, or your 100th time, we want you to know that you're welcome. So if you're here and you have a question or something you'd like to share, please feel free to jump in, because we always like to give time at the end for you to ask whatever question is on your mind.
Would you mind reading something for me?
Sure.
We're going to be doing week 26. We are doing week 26 this coming week, and it's the integral calculus booklet. And I'm just a little unsure still. You put in the charts, so I'm looking at 26.1. You put in the chart how to read an indefinite integral. So I'm just looking here at the top of 26.1. It says read it like this. But I wonder when it's a definite integral, like how would you say the last line of that top section on chart 26, page 1?
Okay,
Do
so
you
I don't have, I don't have the
okay.
lesson, but
Yeah,
you can see my screen. I'm going to do it from this,
yeah,
and then if you can extrapolate from this, that's great. And if
yes.
not, Babs will probably find what you're talking about before I finish. So when we have a definite integral, it means that I have these two limits of integration, which means that if I was to look at my graph, here's my function y equals x, and I say from 4, here's 4, to 7, I'm looking at the area that's only between those two bounds.
Okay, and I recognize that from your flashcards, by the way. Like a
Oh,
definite
yay.
integral is space under the curve, or the area under the curve between A and B, right?
Yep, that's it. So here we have the integral or the definite integral of x, and I would probably actually say I have the integral from 4 to 7 of x dx, or of x with respect to x. So a lot of times we say dx to be quick. What it means is with respect to x. And so that is, it's common for people to say that. Both of those are correct. And then I would say is x squared over 2 Then I draw my line, and my line I would read as evaluated between 4 and 7.
Okay. So the integral from 4 to 7
Yep.
of x as it with
respect to x.
Back to x equals x squared divided by
over
2.
2. And then evaluated at 4 and 7, or between 4 and 7.
Okay. Okay. Thank you.
Where did you get the x squared over 2? Or is that just something you made up, or is that a...
That's the integral of x.
Hey, Kirsty, put the x to the 1 in the original problem and show how the numbers work.
So
because you're integrating it. I got you. Sorry. Okay.
Yeah, you're doing the antiderivative or
the antiderivative, yes. So I add 1 to my exponent, and then I divide by my new exponent. So that's where the x squared plus 2, x squared over 2 comes from. Now, the reason why I don't need the plus c here is that if I had included the plus c, right? So I'm just going to show you here. Let's pretend I had put plus c. What happens is that I evaluate at 7. So I have 7 squared over 2 plus c. And then I subtract that evaluated at 4. So 4 squared over 2 plus c. And notice that when I do this, I have a plus c. I'm going to distribute my negatives. So this becomes minus c, and they cancel out. And so I don't have to worry about the c, and that's why. So that's why I would normally not see that. I'm just going to cross that off so that we see that. And then I would have my 49 over 2 minus 16 over 2 is 33 over 2. So that would be the area under
the curve between 4
the
and
curve
7.
between 4 and 7.
And what unit, like what label would you put on that? Would you say units squared? Would you know?
Well, it is units squared. This is a great question leading into next week, because what are my units when I'm just dealing with numbers? My unit is 1. So my unit squared
Is still 1.
is 1 squared. It's still 1.
Okay. So it's implied. You don't have to say it.
Yes.
If you're using this to do application to a physics problem, you would have units that you can put in, correct?
Okay.
Yes.
But they would be given. They would be given in the problem.
Yeah. Yes.
And Andy asked, what does the plus c mean in the formula?
So the plus c is when we think about the antiderivative, right? So if I'm looking, here's my function y equals x. What that is, when I say the antiderivative, I'm saying what function has this derivative, right? And so what function has a slope of 0 at x equals 0, and then has a slope of 1 at x equals 1, and a slope of 2 or 4 at x equals 4, right? And if we were to do this, we would see, right, it's our parabola x squared. But if we took the derivative with respect to x of x squared, right, it's x squared, I'm sorry, it's 2x. That's why we have to divide by 2, right, to get that. But notice that if I did this, the derivative with respect to x, so this would have had to be, this is a little bit different because I missed my divided by 2. But if I was to look here and say, okay, what about x squared plus 3? Well, the derivative of x squared is still 2x. The derivative of 3 is 0. So my derivatives end up being the same, whether it was +3 or +0, or +7, or plus pi, or minus the square root of 2, right? Every single parabola, right? All of these parabolas, no matter where they are, they all have the same slope. Their position is different, but the slope is the same. And since my derivative is my slope, right, they all end up having the same derivative. So when I find the antiderivative, when I say what function has this derivative, I have to say, well, it was x squared plus 1, x squared plus 2, x squared plus 3, x, right? I'm not obviously going to list them all. So I just say it's x squared plus c. And that c just means it's all of these translations of x squared up and down my y-axis. All of them have the derivative of x squared.
Let me restate that because at
Yep.
first I wasn't following you. Now I do. So basically, that parabola, since that's what's drawn, no matter where that is on the axis, so of x equals 0,
Mm-hmm.
as it moves up and down, I translate it with a value. So I could move it up a half a space or a whole space or many spaces. So wherever I measure it, because I'm taking the exact same parabola and just shifting it up or down, the slope never changed. So in my equation of the parabola, I'll have a variety of constants. But because the slope's exactly the same, I don't care what the constant is. So we just say plus c in one case, which is the integral. And then the thing that's tricky then, Kirsty, is the plus c and minus c are actually there, but they disappear. So it makes you think you never needed it. I'm not sure that I said that any better, but that plus c disappearing changed everything for me. Anybody else want to try? Or are you totally happy, everybody?
I like what you said about it's a variety of different constant.
Mm-hmm.
So one way to explain to the kids would be like, well, you can't spend all this time writing it all out. It would take you years. So the mathematician, just like Beethoven, uses symbols to shorten, like a shorthand thing. So C is actually a shorthand to represent different things. But even when you see the C there, the slope doesn't change. So therefore, you don't really have to worry about the C.
Yeah.
And I've kind of liked thinking,
go ahead, Jen.
I've kind of liked thinking about the C as having the x to the 0th power of x after it. Yeah, when we were doing the derivative, it's very clear. Okay, you're taking the 0 down and that becomes your coefficient. So what's any c times 0 is going to be 0. So that makes it poof. There's a lot of invisible things in math, and you guys are helping us to see the unseen things in math. So that's anyway.
And then would it be is because for this problem we're talking about the slope, and the slope doesn't change because that's the derivative. And then when we talk about the integral, we're talking about the area, and that's where we have to account for the c. But because c is to the because it's just going to subtract out, it's not going to.
Right. So
it does feel like the C would matter, but I mean, because your slope might not change, but if your parabola is way up here, you're going to have a lot more area than if it's.
That's why you have to put the 4 and the 7 in. Or you have to say plus C and not drop it. Is that right, Kirsty? Did I say that right?
Yes. Well, because let me think. Yes, you're right. If a parabola moved up and down, right, it would change
the area under
the curve. But I'm not calculating the area under the parabola. That would be if I was to integrate again, right? And now, yes, it would matter because I'd be integrating again in order to find the area under the parabola. But we're just talking about how do I find the area under y equals x,
Okay.
right? And so now
Yeah.
it almost doesn't matter where I was to draw that, because I'm looking for the difference between the area here and here, right? That's why those cancel out, because I'm not worrying about its position at that point. Now, when we're talking about, right, so that's a different picture of what we're looking at compared to looking at it, this is an antiderivative, right? Because then we're saying, if I take the derivative of this, I'm going to get my y equals x, which means I really, just to be clear, in case anybody's watching, I should have looked, right, at all of these. So I would have had y equals x. So it would match what we were drawing here. So I just wanted to clarify that I did not have my integral, or wherever I messed up one of those, right? Yeah, I would look at the derivative of x squared over 2 would give me my y equals x. So that's when I'm looking at them as antiderivatives versus what does this mean that it's giving me area. I think it's harder to think about comparing the value on our integral to the area. I just think that that's hard to wrap your head around. It's not as obvious to see. And that's why I tend to talk about the integral in terms of the antiderivative, because I can see how it collapses back down to that function. So anyway.
Well, I think something you did that was helpful was in the charts for these two lessons, 25 and 26. We would show, in the first one, we showed the formulas for, what's the first? I forgot, the derivative. And then the next one, we showed the derivative. So, sorry, back up. So we did the function and the derivative. Then we did the function, the derivative, and the integral. So you could compare symbolically. So I'm thinking through this conversation, as someone like myself who's very good at patterns, I could probably derive all day long and not have no idea, or integrate and have no idea what I just represented. Then you've got your other students that are really good at geometry and seeing things, but boy, do those symbols scare them. And what we're trying to do by making this, saying that we want to see the unseen, is to give some lessons that allow the students to take just these 16 basic equations and do them every year with images, with an equation, and with their 4 basic manipulations over and over again. Because we recognize most students, unless they just love math, don't even understand what they're doing at all when they go through their calculus lessons. So I'm hoping, that over time this will help. You mothers have been certainly encouraging that it is helping. But to see how the symbols connect with the images at the same time, I find it very helpful.
Now, Andy, you were the one that asked the question. So has this helped you, or do you want to work through this again?
No, that was very helpful. Thank you.
But for people who are listening that have no idea what any of this meant, please take heart, because I've never had calculus. I've never, even a year ago, I would have just sat here very quietly and not known a question to ask even. And now I'm beginning to sort of, kind of a little bit follow the conversation.
Well, and Jan, I appreciate that, because I also want to say, right, I did all the math classes, right? I did all the graduate math classes. I did this, I had this. But in terms of really stopping and comparing, like Lee said, taking a look and saying, well, what does this really mean? Right? It takes time, right? It really takes time to say, and this is where, if you want to, this might be a great summer project to dive deeper into with a student who's curious, right? Is actually take, I'm gonna say acetate, and I don't even know if they use that word anymore, but like a, piece of, like a sheet protector or something like that, and draw your function on the sheet protector, right? And then just literally slide it up so you can see what would be x squared over 2 plus 1, x squared over 2 plus 2, right? So you see this is the same exact curve, just in different places, right? And then talk about, has my slope changed? And start with, oops, there we go. Start with, if you were going to do this, you could start with a really simple function that your students might find more familiar. Right? Start with y equals x. Right? And then you could even say, okay, what's my slope? Well, remember it goes in this form, mx plus b, so m equals 1, and in this case, b equals 0. And then slide it up and go, okay, what's my equation here? Y equals m, well, it's x plus 2, for example. Well, so m equals 1, b equals 2. And just do it with this, right? Sliding that line up and down, not left and right. That kind of changes things, especially with our other functions. Just sliding it up and down. So all you see, my slope is never changing. All that's changing is that b value. Right? So now if I was to take the derivative, right? And all I'm thinking is my derivative is my slope. So don't worry about calculating your derivative. Don't worry about graphing your derivative. Just go derivative is slope. As I move this up and down, is my slope changing? Right? Nope, my slope is always 1, no matter where I slide it up and down. This is a great opportunity to practice the equation of a line, right? Identifying our slope and our y-intercept, and then going, okay, we're just going to practice that derivative is slope. Did my slope change? Nope, it didn't. So if I said y equals x plus b, my slope is always 1, but I'm saying this is all the lines that have a slope of 1, right? That's the same thing as saying y equals x plus c, right? It's just so there's a connection to this equation of a line, right? And so when we're talking about equation of a line, we use b. I don't know why, right? Somebody somewhere chose b as our y-intercept. And then in calculus, we go, oh, right, when I want to talk about all of the possible values of my y-intercept, we're just going to use the letter C instead of B.
There's a book called Calculus for Everyone. I thought that was really fun read for me to understand calculus, and what you just put on the board somewhat makes sense because of that book. So, and then my son is reading it too. It has good cartoon drawings, and isn't the same author that wrote the math of bad drawing or something like that? Yeah, and
No, it's a different author. It's Mitch Stokes.
oh, okay, yeah.
But go ahead. But it's a great book. I mean, so that's why he's in the physics program.
Okay. So, oh no, I think it's not calculus for everyone. It's is it calculus for everyone? What's
Oh, I
It
don't know.
says
Maybe it's a different book then.
change is the only constant.
change is the only constant. That's the book. Yes, change is the only constant. It's really a fun read for calculus.
So, but yeah, those are the kinds of things that I would say take the time over the summer. Don't all of these ideas that we shared, don't try to do them all, but see where your family is and pick something. And it might be this is the summer we're going to go deeper into a couple of things. And so this is the kind of thing that you can do, and not just do once, but do it over the course of a few weeks so that you get really comfortable with one idea, right? And so I just want to encourage us all to use our summers wisely, to continue that conversation, so that when we come back in August and we start again, we're starting from a step up and not a step down from where we ended the year. Are there any other questions? All right. Well, thanks everybody for being here. We always enjoy our conversations, and I hope that if you were new, that you'll come back. And next week we're going to have fun talking about what counts as a unit. So bring your ideas.